All right, hi guys. So today for your video notes, it's all about wind, where wind comes from, why it forms, the different types of wind. So we're starting off with really the easiest definition all year. Wind is just simply moving air. That's all. It gets a little more complicated when we talk about what causes it. So for what causes it, the wind is created because of differences in air pressure. So we've talked a lot lately about how things on this planet in nature, they don't like to be so extremely different. They're trying to blend. They're trying to equalize and get to one common temperature or pressure. So when there's different pressures up in the atmosphere, like a pocket of high pressure and a pocket of low pressure, they're going to try to blend together, and that movement of mixing causes wind. And the greater the difference, the faster the air will move. And it's usually going to be happening because of unequal heating. So that goes in with albedo, like what we've been talking about in class. So if you have above a city a much different air pressure system because it's so warm versus out in the country, that could cause some wind movement to occur. And it's always from high to low. Higher pressure always flows to lower pressure. So there's an important instrument you need to know. It's called an anemometer. It measures wind speed. We actually have one here above LT. It's above Mr. Shank's room. So you'll see it spinning around and moving. It shows how fast it goes, and also there's this, we call it the wind vane, which will tell you what direction the wind is coming from. Okay, so there's really two different types of wind systems. First, we're going to talk about global. So global, it moves on a much larger scale, moves very large distances and circulates across the whole Earth, since it's global. The temperatures are going to be circulating from convection cells. So you can see in these different cells all around the globe, it circulates, the heat rises and the cold sinks. And so it creates these different zones of global wind systems that will impact around the different latitudes of the Earth. And so I'm going to go over the most basic zones of the global wind systems. So the first one is called the trade winds. These are the ones that blow from 30 degrees latitude down to the equator. So it's in both hemispheres. So you'll see these are the trade winds as they both converge on the equator. The next zone that you would need to know, they're called the westerlies. So these are the winds that blow from 30 degrees to 60 degrees latitude in both hemispheres. So this is what affects Kansas. We are in that temperate zone of the westerlies, so we're right here, which is what most of the United States is. So if you look at the Weather Channel, you want to know what weather is coming, you don't ever look to St. Louis. St. Louis is getting the weather that we are experiencing currently. So if you want to know what's coming our way, you would look at western Kansas. So they're called the westerlies because that's where they're coming from. They're coming from the west, blowing to the east. And the last one are the easterlies. So these are up at the poles. They blow from the poles down to 30 degrees latitude. And just like the westerlies, they're named from where they come from. So they blow from the east and they move to the west. Okay, so that's global winds. Let's talk now about local winds. Local winds are going to move shorter distances, and they can blow in any direction. There's no rhyme or reason to it. This is really more controlled by the geography of the area. If there are lakes or ponds nearby, if it's really hilly or flat terrain, that will shape the geography of the area. And so kind of a good thing to understand is that the surface temperature will be creating different kinds of pressures. So cooler air has a higher pressure because remember we talked about cold sinks. So if it's closer to the surface, you can imagine we talked about that column of air pushing down on you. They're going to have higher pressure because they're going to be so low down from sinking from the cold air that they're going to be experiencing higher pressure. Whereas warm air tends to be lighter as it wants to rise because it's warm. So it's higher up, which means they're going to have lower pressure put on them. And this is important to know when we talk about the next two things. So there's a phenomenon that happens called a sea breeze. So if you live or you're visiting near a coastline, you can expect this to occur. So a sea breeze happens during the daytime where the land or the sand, if you're at the beach, heats up faster than the water does. So that we just did that lab where we put light on the sand or the water. So you should have learned that the water takes forever to heat up, whereas the land really heated up really fast. So that's where your warm zone is going to be. And the water will be much cooler during the daytime than the land is. So your cold air above the water will be having a higher pressure. So your high pressure zone is out at sea. And your low air pressure is above the warm land. And high goes to low. So you get a nice cool sea breeze blowing in from the ocean to the land during the daytime. Okay, so to demonstrate that, I'm going to have you draw a picture in your notes in the space that I provided for you, just to remind you of what a sea breeze does. Okay. So you have your coastline, and this is the sun because it's daytime. The water is colder. The land is warmer. The cold water will have a high pressure, and the warm will have a low pressure. And since high pressure goes to low, that's where the wind is going to go. So that's your sea breeze. Okay. Last, it's called a land breeze. So a land breeze, again, if you live or visit near coastline, land breeze happens at nighttime. So what happens here is in the lab, what you should have seen is that the land, the sand, that we were testing, it heated up really, really fast, but then as soon as you turn the light off, it cooled down really fast. It did not retain that heat for very long. Whereas the water, it takes forever to heat up, but when that light went off, it slowly cooled back down. So water retains heat much, much longer, and it's very slow to cool back down. So at nighttime, the water will actually be warmer, and the land will be colder, which means now your high pressure zone is above the land, causing the wind or the breeze to go from the land to the water. So it just goes in reverse. So for your picture on this one, it's just basically the opposite. So you've got your beach again, This time it's nighttime, so you're going to draw a moon. And your land now is going to be colder. Your water will be warmer. So the high pressure zone is now above the land. So now that breeze is going out to sea. So if you were to visit a coastal area at nighttime, you're not going to smell that salty sea air like you would during the day. Okay, that's it for your notes today, guys. Bye.